All right, let's take a look at where we left off last time. In between tutorials, as I was preparing for this lesson, I expanded the ground a little bit. And you can see here that we have it following the waypoint system. You get the idea. I'm going to make this a little bit slower just because I want to remove some of that snapping until we fix that in code. The next thing I want to do is create a player, because what good is having this non-playable character walk around, which could be like a ghost that we sneak up on or whatever your mind. Or like I said, it could be a dog and then it starts to follow you and it becomes your pet in the game. But for now, let's right click in here and let's go to 3D object and let's make a capsule. And this is going to represent our player. So let's go ahead and rename this player. Now the other thing we want to pay attention to is I'd like to give this some physics. We're going to be using a previous script that we created, but I'd like to add something new, like make the character jump. So let's add let's actually make a folder in here. I made one called NPC. I'm going to drag my move to waypoint into there. And that's just, as you know, stands for non-playable character. I'm going to make another folder here, and I'm going to call this player. So what these are these just any scripts that have to do with the non-playable character or the player we're going to put in here. So yeah, let's go ahead and right-click and then create a C# script that is for the player. So create C# script, and let's name this character movement. And I'm going to double-click this and open this in Visual Studio. Actually, before we do that, I want to make sure that I add a rigid body here. Now, if I press play here, because of the shape of the capsule, if I even give it a little bit of a rotation, you'll see that it can fall down. So I'm going to remove that rotation. I'm also going to lock its rotation maybe, let's see, I don't know if I want to freeze its position on the y-axis. We'll try that in a second. We'll script it and then we'll play with these constraints because once we start moving our character around, it'll actually fall over. So what I'm going to do is I'm going to open this script up, and I'm really just going to paste in the code that we wrote before and then just re-explain it. All right, so let's look at the top here. Again, you've seen most of this before, but this is really just the speed in which the player moves. And what I would do is just kind of pause it as we go through. And then here we're scripting how fast our character can rotate, which is helpful because as we're moving forward, we sometimes want our rotation to be a bit snappier. Otherwise, it ends up making these long turns. We're going to add a rigid body here to control our physics. We're going to actually grab that component, and we're going to be using that for our movement. So if you remember before that this float horizontal is grabbing the input that's called horizontal inside of Unity's input system. So horizontal is actually mapped to A and D, and vertical is mapped to the W and S keys. So then we're going to create a new vector 3. And if you recall, it's vector 3 stores 3 values, the X, Y, and Z. So we're going to grab its Z value or its forward value, and we're going to multiply that times our vertical here, which is our speed, and then we're times speed that we created earlier, and then we're going to normalize it by time.delta time. This rigid body move position is what actually moves it. So we're going to use this movement here, and we're going to add it to whatever our current position is. The way that we're going to rotate it is using those horizontal, the A and D key values. We're going to make a new float that's just storing, if we're pressing A, we don't necessarily need to make this a vector because we're only storing one value. But if we're pressing A, we're going to multiply that by rotation speed, to speed it up. And then we're going to normalize it by using time.delta time. Quaternion delta rotation, you could just think of this as a variable that's storing our current rotation. And then we're going to apply this rotation later here. So the angle in which we're rotating is based on a new vector, and it's on the y-axis. And we're feeding into the y-axis, we're feeding into the y-axis this rotation variable here. So again, I know we've seen this before. If you'd like a little bit more detailed tutorial on quaternions and stuff, let me know. I'd be happy to make one. And then our rigid body move position, and then we have move rotation. So this is actually what's rotating it based on this value here times how we smooth it out here. So this is what's kind of controlling that. So I'm going to save this. And then what I'll do that is new is I'll probably add a jump. So let's go back in Unity and see this working. All right, so now when I press play, you can see I can, did I not attach? I think I did not attach the player movement script to it, or the character movement. So rotation speed is set to 100. I'm going to set it to 200 because I tend to like faster rotations. And now you can see as I'm moving around, it's on you could see the z-axis here. Now, did you notice that it fell over when I left it alone because of the shape of the capsule? So it's like if we move this around. So how do we fix this? Well, I'm going to wait to fix it because of the I'm going to add jump in a second. So once I add the jump, we'll take a look at which one of these axes we'd like to freeze. And I'm probably thinking of the x-axis. So let's go ahead and jump back into Visual Studio and add the jump. All right, so the first thing I want to do is add another variable. I'll add it up here. And it's just going to be jump force. So as I hit maybe spacebar or something, it'll add this much force. And then we made it public so we can adjust this. It'll add that much force to the rigid body. All right, so let's go and a little bit down here, and let's add an if statement here. And what this is going to do is, if our input.getButtonDown jump and is grounded. So is grounded is a Boolean variable that I forgot to add up here. So let's do Boolean is grounded equals, and then we can leave it at false. Actually, what might make it cleaner is, let me get rid of this. And I think my initial intention is to create a function called isGrounded. So let's go ahead and do that. So if our input get button down is set to jump, and jump is our space, it's set to our space key. And let's go ahead and actually jump back in Unity, and I'll show you how I know that's set to space. All right, so here we are back in Unity, and if I go to Edit and then Project Settings, and I go to Input Manager, notice there's a keyword here called jump, and the positive button is set to the spacebar key on our keyboard. So let's go back to Visual Studio and let's finish that isGrounded function. All right, so if we press the spacebar and we are grounded, which means our rigid body is touching the ground or the floor, really if the y-axis is colliding with the bottom or it's set to 0, we're going to apply force. And we're going to set it to the y-axis, and that's going to be multiplied by that 5, the value 5 that we created earlier. Now, impulse is what that does is that's the way that it accepts the force and it smooths out that movement. So notice that this update function ends here. So we want to go below the update function. So sometimes it's helpful to do something like that, especially when your code gets pretty big. So let's say we do a public void, and then we'll just copy isGrounded here. I love IntelliSense, but it does its best to guess what we're trying to do. So let's go ahead and let's see. We're still inside of our class here. You know what? It's not a void. It is a Boolean. Sorry. So what we did here is we're checking if this is hit, and when you're calling a function like this, you have to, because it's checking if this statement is true or false. Like, did this jump be pressed and was this set to true or false? So this has to be a Boolean value, which means 0 or 1 or true or false. We want to do some stuff. And so let's go ahead and just go through how we did this. So a raycast is this invisible laser. It's sort of like this. It's checking a ray or light that's projecting from the character. Well, how do we know where we want to project it? Well, if we do physics.raycast, we want to go from the center of our character or wherever that position is. So remember, our character has a X, Y, and Z axes that's set in the center. On the y-axis, we're going to go minus, which is facing down, and we're going to store whatever we hit in this variable, out hit. And we're just checking if we're within 0.1f. Now, if we do hit the floor, that means we're really close enough to almost 0. We're going to return true here. So if we press the spacebar and we are grounded, then we can apply that force again. else will return false, which will allow us to not hit spacebar. The purpose behind this is if we don't do something like this, if we keep hitting spacebar, it'll just keep going infinitely to the top. So let's go ahead into Unity and let's play around with this new toy that we just created. Here we are back in Unity. I'm going to go ahead and press play. Now I'm walking around. Press spacebar. This doesn't really seem to be jumping. Maybe the force is too high. So here's our player, or the gravity is too high. Because on our rigid body, notice we have mass. But let's add maybe 100 to jump force and see if that goes really crazy. I might be missing something here. Let's see. Maybe we take our force down. Let's see, our mass 2.1. No, we should get a little jump there. Okay, let's return to Visual Studio and see where I might have forgot something. Okay, I could see the problem here. This is set way too low. And this is really checking the distance. We don't necessarily have to have it near 0. We can just do like 1. And so, because it's going to come up and down so quickly that like by the time it hits that area that they'd have to really hit spacebar quickly to get it to do that floating thing I was talking about. So let's save this, and let's also alter some of the attributes of our capsule inside of Unity to make sure the jump looks smoother. All right, so let's try making this jump force maybe 10. Let's press play and see how that looks. That's still too high. Maybe 5. And you could play with the angular drag as well as the mass here. So let's see. There we go. So I hit spacebar. You can see we kind of get a little bit. And then let's look at, kind of want to make the jump force. We could play with the speed too of the jump force. But so that it doesn't fall over, maybe if we freeze the Y rotation, let's see if that does, if that fixes it. So our character isn't sort of falling. Was it falling? Yeah, it looks like it's falling. It looks like it's falling on the X. So let's freeze the X-axis. See if that makes it fall. Yeah, looks like that fixed it. Oop, nope, didn't. Let's do also the Z. So that way, because we want it to just rotate on Y, we don't want it to always fall. Oh, but if we freeze the Z. Oh no, yeah, that looks good. We can still, we almost have to kind of stop to get it to jump. But for now, we might have to play with those values a little bit better for the jump. All right, so the last thing I'm going to do is maybe just add I'm going to hit Control D on this line, and I'm going to do a jump drag, and we'll set that to 2, and we'll save this. I'm going to copy jump drag, and I'm going to paste it in as this 4th parameter here, and that way, when we go back into Unity, let's do that. We can play with the amount of jump drag. So I thought 2 actually was a really good number. I can actually jump a lot. It's pretty responsive. Makes the character move smoother. I mean, if I hit F to focus on my character here and zoom out a little bit, you can see jumps pretty good. We're moving. Last thing I'd like to do is maybe have the main character follow the player around. So I'm going to take the same main character script that we used in the helicopter tutorial. I'll re-explain it pretty quickly, and we will do that in the next video.